Good morning friends. Today I am going to explain what are Newton rings and how these rings are formed. In optics, these Newton rings are very important because by utilizing these Newton rings we can find out the wavelength of the any light, and at the same time we can find out the radius of curvature of the plano-convex lens, and we can find out the Young's modulus by forming these Newton rings. And these Newton rings are first observed by the scientist Newton. So that's why the name of these rings are Newton rings. And in this Newton rings experiment we need three things, that is plano-convex lens, plain glass plate, and a monochromatic source of light. What is plano-convex lens? The plano-convex lens means a lens whose one surface is plane and another surface is a curved surface. And what is monochromatic source of light? That is a light which is having only one wavelength or single wavelength. When this combination, that is when a plano-convex lens is placed on the plain glass plate, an air film of thickness T is gradually increasing from center to outwards. Okay. Now, when a light AB is incident, then some part is gets reflected and some part is gets refracted. The reflected part at point C gets out as a ray 1, and the refracted part goes as CD and gets reflected at point D and goes out as R2. And these light rays R1 and R2 are interfere to each other. Because of this interference, the alternate dark and bright fringes are obtained. So these dark and bright fringes are known as the Newton rings. What is interference? That is when two lights are superimposed to each other, or the addition or combination of two light rays, first and second, then that is known as the interference. Sometimes the constructive interference takes place, that is crust of a first wave is falls on the crust of the another wave, so that is known as the constructive interference. And sometimes crust of a one wave is falls on the trough of another wave, so this is known as the destructive interference. Okay, anyhow, here due to the interference pattern, a number of alternate dark and bright fringes are obtained, and these number of dark and bright fringes are known as the Newton rings. Here, two more points you have to remember. When these light rays are R1 and R2 gets reflected and interfere, here the R2 is coming from the denser medium to the rarer medium. So according to the Stokes law, whenever a light ray moves from the or gets reflected from the denser medium to the rarer medium, it suffers a phase change of pi, and at the same time we can say that is a phase change of pi or a path difference of lambda by 2. And at the same time, according to the cosine law of interference, when the light rays reflected from the surface of a transparent film of thickness T, then these two light rays having the path difference, that is delta is equal to 2 mu T cos R. Okay. Now, by applying these two laws, that is cosine law of interference and whenever the according to the Stokes law, that is whenever the light ray is refracted from the denser medium to the rarer medium, it suffers a phase change of pi or the path difference of lambda by 2. Then the total path difference between R1 and R2 will be 2 mu T cos R plus lambda by 2 for air film. So here the air is there, so air film, the refractive index is 1, and for the normal incident angle of refraction is 0. So therefore when you substitute this, r is equal to the 0 and mu is equal to the 1, the path difference is equal to delta is equal to 2t plus lambda by 2, because the cos of r or cos 0 is equal to the 1. Okay. Now the central spot is dark. Generally the central spot in the Newton rings is dark because here the air film thickness is 0. The central spot is dark because at point of contact T is equal to the 0, and hence the path difference delta will be equal to the lambda by 2. T is equal to the 0. The path difference lambda by 2, which is the condition for the minimum intensity. So here we are getting a dark fringe or less intensity, or we can say that is minimum intensity at the point of contact of the plano-convex lens and the glass plate. Now for the nth maximum, we have the condition the path difference between the two reflected light rays must be equal to n lambda. So generally path difference we got 2t plus lambda by 2 is equal to n lambda. For different values of t, different maxima will be occurring. Here the t will be different at different points. So that's why we will get different maxima will be occurring, and the maxima will be gradually decreasing from center to outward. Okay, so this is about the Newton rings.